Hello, in today's video we're going to be discussing section 5.2, which is on solving systems of linear equations by substitution. Previously we solved by graphing, which can be a little bit inaccurate if your graph is skewed in any way. But I'm going to go ahead and ask us to start by reviewing solving systems of equations by graphing before we go on to address our essential question, which is, how can you use substitution to solve a system of linear equations? So please pause the video now and practice solving the systems of equations that are shown here by graphing. You can go ahead and check my work for both of these and compare it to your own. But my first line I've done in blue, second line in red, giving me a solution or a point of intersection at 3, -1, which means if I put a 3 in for x in both of these equations, the y value that I'm going to get out is a -1 for both equations. That's the only place where I put in the same x value and get out the same y value. For my second system of equations, my x value is 1 and my y value is a -3, meaning if I put a 1 in for x in both equations, I'm going to get a -3 for y in both equations. That is the only place where I can put in the same x value and get out the same y value. Now we've talked about how graphing can be a little bit inaccurate. If your lines are at all not straight, or maybe you don't plot enough points, or maybe you don't number your graph consistently, or maybe you're hand drawing your graph and your axes are not measured in equal increments. All of these reasons and other reasons might cause graphing to give you an inaccurate answer. So we have two other methods that we talk about. When solving a system of equations, regardless of how we solve, we are looking for the one point that is the solution to both of the equations. Or, if we think about this graphically, we are looking for the point where the lines intersect. So one method that we solve by is by graphing. But as I have said, this can be inaccurate because it requires you to draw extremely precise graphs and extremely precise lines in order to find the exact solution. If your solution is not a whole number or an integer, maybe it's a fraction, finding that solution becomes even more challenging. So we have two other methods that we can solve by. The first method is by what we call substitution, and the second is elimination. So method 2 is substitution, and method 3 is elimination. We're going to be focusing on solving systems of equations by substitution in this video. So the general idea for solving by substitution is that we need to substitute something. Just like you might have a substitute teacher comes in and replaces your teacher for the day. Solving by substitution means that we are going to take one thing and replace it with another, just like a substitute teacher replaces your teacher. So the general idea is that we are going to replace or substitute one of the variables in our equation so that we can solve. So we're going to go ahead and start by solving the systems of equations by substitution. And then, of course, we'll interpret our solution. So here is a system of equations. I am telling you that y is equal to 2. That is one equation. And my second equation is that x plus y equals 5. So if I were to graph this, I will just sketch a very brief graph. I would have a y value equal to 2. So that first line would look something like this. It is a horizontal line where y is always equal to 2. And then my second equation, x plus y is equal to 5, would look something like this. We have a y-intercept of 5 and a slope of -1. So what we are looking for is that point of intersection. We could, of course, graph, but to make sure that our solution is precise, I'm going to solve by another method, in this case substitution. So step 1, isolate one of the variables. This word isolate means to get alone. So get one of the variables alone. So in this case, I have an x and a y, and I want one of those variables alone. Well, if I look in the first equation, y is alone. On the left-hand side of the equal sign, the only thing that I have is a y, meaning that it has been isolated. So step 1 is done. So step 2, substitute this value into the other equation. So what we're saying is that we know y is 2. Y and 2 are exactly the same thing. They look a little bit different, but they are exactly the same. It's somewhat like 4 quarters and a dollar. 4 quarters and a dollar have exactly the same value, but they look a little bit different. If you go to pay for something that costs $1, you can either use 4 quarters or you can use $1. So here I've got a y and a 2. I can either use y or I can use a 2. They are exactly the same thing, they just look different. So I'm going to take what y equals, this 2, and replace it for my y in the other equation. So that's essentially like saying I have $1 here, but instead I'm going to put 4 quarters in that spot. They look different, but they are exactly the same. So in that second equation, I've got x plus y is equal to 5. But we know that y is equal to 2, so I can put a 2 in that spot. And now this is an equation that I can solve. X plus 2 is equal to 5. I subtract 2 from both sides. And I find that x is equal to 3. Great. So step 3, we solve that equation. So we are done with step 2, and we are done with step 3. Because we substituted, we had only one variable in my equation now, and I was able to solve and figure out the value of that variable. So I know that x equals 3, but since we are solving for x and y, I need to find y. So step 4, substitute this value. Now that I know what x equals, I'm going to go take this value and solve for y. So going back to my 2 equations, I've got 2 options. I can use my first equation or my second equation. Since I already know that y has to equal 2, I'll go ahead and use that first equation. So my solution here is that x is 3 and y has to be 2. So the point 3, 2 is the point where the 2 lines intersect. It is the only place where I can put in the same x value of 3 and get out the same y value. I'll walk you through one more, and then I'll ask you to practice a couple on your own. So I'm going to go back through all of my steps. Step 1, I need to isolate one of the variables. So I have an x and a y, and also in the first equation an x. I want one of those variables isolated or alone. Well, in this first equation, I see that x is alone on that left-hand side. So in that first equation, x is isolated. So step 1 is done. Step 2, I'm going to substitute this value into the other equation. So again, x is like my $1, 5 is like my 4 quarters. I'm going to go ahead and put in that 5 for x. Be very careful that this is multiplication. 2 times x minus y is equal to 13. Instead of x, I'm going to replace my 5 for that x. And now I can solve this equation. 2 times x, or 2 times 5, is 10, minus y is equal to 13. I subtract 10 from both sides. I have a negative y is equal to 3. And now I need to get rid of that negative. The negative is actually a negative 1 in front of my y. So I'm going to go ahead and divide by that negative 1 to get y by itself. And when I do that, I see that y is going to equal 3 divided by negative 1, which is a negative 3. So step 3 was to solve that equation for y, which we did. So now we are on to step 4. Step 4, we substitute this value of y, being negative 3, back into our equation to solve for x. So I can replace it for any y that I want in the first equation or the second equation. But in that first equation, I already know what x equals, so I know that my solution has an x value of 5 and a y value of negative 3. So that point, 5, negative 3, is the point where the two lines intersect. Go ahead and take a moment to pause the video and try these next two on your own. Now I know that x is a -1 here, so I'm going to go ahead and replace that -1 in for x. So 3 times -1 minus 2y is equal to 11. -3 minus 2y is equal to 11. This is a -3, so I add 3 to get that -2y by itself. So this is a -2y is equal to 14. And dividing both sides by -2, I find that y is equal to -7. So I know that my y value is -7, my x value is -1, or you can replace y in this equation and solve for x. Either way, you will get an x value of -1. So -1, -7 is the point where the two lines intersect. Similarly, for our second one, I'm going to replace y, so I've got x minus 2 times y, which is -3, is equal to 8. X plus 6 equals 8, and subtracting 6 from both sides, x is equal to 2. So we found that 2 for x, and then we know y is -3, is the point where the two lines intersect. In these examples, we are going to go through the same process, but at the end, we're going to need to do a little bit more work to solve for our other variables. So step 1, make sure one of your variables is isolated. Here, y is alone, so I can go ahead and move on to step 2, which is to substitute this value into the other equation. So in my other equation, everywhere I see a y, I'm going to put a 2x. So x plus y is equal to 12, but y is actually 2x. So x plus 2x equals 12, 3x is equal to 12, which means that x has to be 4. So step 3, solve, we have completed that step. Now step 4, I need to find my other variable. So what I'm going to do now is say that I know my x value is 4. So if I put in that x value of 4, I will get the y value that should pair up with that 4. So I need to now replace my x with a 4 to figure out what y is. I can do that in the first equation, or if you prefer, we can do it in the second equation. I'll go ahead and do both to show you that we would get the same answer regardless. So plugging it into my first equation, I've got y equals 2 times x, which is 4, so y is equal to 8. Or I can plug it into my second equation. X plus y is equal to 12, which means that 4 plus y is equal to 12. Then subtracting 4 on both sides, y is equal to 8. So either way, when I put in a 4, I get an 8 for y. So 4, 8 is the point where the two lines cross or intersect. Go ahead and pause the video and try this next example and the following two on your own. For that first practice, I got 9 and -3 as my point where the lines intersect. Next, I've got 9, 18. And your last practice, you should have a solution of 10, -2. Pause the video to check out my work as necessary if you have not agreed with any of these solutions. The last thing I want to talk about is something you're going to come across later, where we only need to find the x value of the solution of each system of equations. So once we find the x value, we are done. So for example, I'm going to go ahead and solve this first equation. When I substitute y with 2x and solve that equation, I get an x value of 7, so I am done. In my next example, when I solve, I get a y value, so I need to go plug that in to find x, and x is 25. Thanks for watching. Have a great day.